Welcome to the first video that we're going to watch on in Algebra 2 this year. This is how every day in class will go. You'll watch the video at night for homework, and we'll come back during the day and actually practice and discuss and things like that. The first video is a video that discusses some of the items that we feel you should know before you get into Algebra 2. One of those are called number systems, and it's basically the types of numbers that are out there and what do they mean and how do they fit together. The second is a few properties that we expect that you know, both in name and in look. And the third thing are conversions, which you do in chemistry. So if you've had chemistry, this should be a pretty nice section for you. Otherwise, it's going to be some idea of how do you go from one item to the next. And we'll show you all three of those. I apologize for that. Let's look at this as we go through. Okay, the first thing, let's talk about number systems. Basically, every number that you think of currently are what we call real numbers. And just fill in the blanks for me as we go. The real numbers are everything we think of, and they include two subgroups, which we call the rational numbers and the irrational numbers. Okay? And you know, let me actually spell this correctly. You know both of these, maybe not by name, but you do know them. And so what I want to do is I kind of want to make a little picture here on the left. And so I am going to create kind of this box or this oval. You can kind of create whatever shape you want. And I'm going to split this up. This is the real number system. So as we think of every single number, we're going to put it in this oval shaped item. Now I'm going to cut this in half. One half are the irrational numbers, and the other half are the rationals. And we're gonna keep going from there, but I'm gonna show you how everything relates. Now let's talk about what these three terms mean, since we've discussed them already. Real numbers are everything on a number line. They include decimals that have an ending point, like 0.5. Like there's an actual end to your decimal, or decimals that repeat, such as 0.3 repeating. Now we know that's 1/3, but that's that general idea. Or are infinite and do not repeat. Things like the square root of 2, which is a decimal that keeps going on and on and on and on. But because of this, these real numbers, think of other numbers you know. You also know like whole numbers. I mean, you know 0. You know 7.293. I mean, there's all these bunch of numbers that you have an idea of that fit into the real number category. Now, these could be positive, these could be negative, it doesn't matter. Now, let's split this up. Rational numbers are numbers that can be written as a fraction, and we actually call that a quotient, but we'll go a little easier today. They're a fraction of two integers. And so decimals either have to have an ending point, because let me go back to this. Negative 0.5 is the same thing as negative 1/2. It's a fraction where there's a number divided by a number, or they have to repeat, such as, let's do 0.3 repeating is the same fraction as 1/3. And so these are kind of the idea as you go through. Now, 5 is still considered a rational number because you can write this as 5/1 or 10/2. Because it can be written as a fraction, 5 is still considered a rational number. Now the other type are irrational numbers, and irrational numbers don't repeat, so they do not repeat. Let's start there. And they are infinite in length. That means they go on forever and ever and ever without any repetition. Now, you're thinking irrational numbers are something like the square root of 2, where it's not a repeating decimal and we don't know the end of it. Pi is another irrational number that you know of, because again, it's 3.4 blah, 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 right? And you know that that decimal does not end. And so this is the idea as you're going through. So you can break it up into rationals that end or or irrationals that don't end. Okay? Now, inside the rationals are what we call integers. And integers are positive or negative, and they have to be, I'm going to call them a whole quantity. So you can't have any decimals in integers. It's got to be a whole quantity, like negative 12 or positive 84, even 0 as we go through. And so inside this rational category, we knew that rationals were two integers. Inside of this rational half of an oval is what we call the integers, because rationals are made up of the fraction of an integer. The other thing we have within this subgroup is whole numbers. Now, the difference between integers and whole numbers is these have to be positive. Okay? Now, as we go through, one thing I do want to start with, whole numbers, though positive, I say positive, but it also starts at 0. So I'm going to call it positive and 0. So we're talking about the numbers like 0, 1, 2, 3, 4, so on and so forth. Now, because these whole numbers are included in the group of integers, we're going to put an extra subgroup in here and put whole numbers in there as well. So whole numbers are part of integers, and integers are part of rationals, and rationals are part of real numbers. Rationals and irrationals, though, never mix. Okay, and so this is kind of the idea of how numbers kind of go together. We do expect, though, that when we say write your answer as an integer, that you know that it's a whole quantity. It could be positive or it could be negative, but we need you to understand that. So here's what we're going to do. We're going to put these ideas, and we're going to put them on a number line. So let me move this down. Now, as I look at this, place the following numbers below on the rational, or on the number line. Rational numbers need to go below. Irrationals, we just want to write the answer above. And the only reason we're doing that is to kind of separate them. Now, I look at this and I know a couple of numbers. I know negative 6. I know negative 3.2. I know where 1/2 is. Pi, I can kind of figure that out. Square root of 3, I don't know. Negative 0.2, I'm okay with. Okay, now I look at some of these and go, I don't know what the square root of 3 is. Well, what I can do is use my calculator, and if I put it in my calculator, the square root of 3 is 1.73. And pi, we know, is 3.14159. So I can kind of look at these this way. Now, I need to have numbers from a negative 6 to a positive 3, or I'm going to say positive 4 just to go higher. So I'm going to label my number line, and I said I had to go to 4, so I'm going to put 4 here, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, so on and so forth. So you can kind of see, when you label a number line, you cannot just make one line, here's the square root of 3, and one line is 3.2. I mean, it has to actually be the same interval as you go through. Now, as I look at this, let's label some of these. Here's what I know. Negative 6 is here. Is it rational or irrational? Well, it's rational because it's made up of an integer. And so I'm just going to put negative 6 down here so that I know. Okay, and we said rational numbers were on the bottom. Another one that's rational is negative 3.2. Well, here's negative 3, and I need to go farther back, 0.2. So negative 3.2 is like here. This is also rational because I could, if I wanted, write this as a fraction. Okay, negative 32 over 10 would be the same thing, or in reduced form. 1/2 is a positive 0.5 if I'm doing this in decimal form. So 0.5 is halfway between 0 and 1. Because it's rational, it's a fractional form, we're going to put 1/2 below. what else do we have? Pi is 3.14. So positive 3 and another point in between 0.1 and 0.2 is here. Because pi is a decimal that does not end and does not repeat, it's considered irrational. Now, when I go to put this on a number line, I want to go back to my original pi and don't use your decimal version. The square root of 3 is 1.73, so it's between 1 and 2, but closer to 2. And again, it's irrational because this decimal doesn't end, it actually keeps going. So the square root of 3 is what we want to write on top because it's an irrational number. And last but not least, negative 0.2. It's between 0 and negative 1. So negative 0.2 repeating is about here. Because it repeats, it's considered rational. And so we're going to write it down here, negative 0.2 repeating. Okay, so this is one idea. Now, I may not necessarily make you put it on a number line later, but I will have you write them in order. And if I ask you to write it in order from lowest to highest, we would say negative 6, negative 3.2, negative 0.2 repeating, 1/2, square root of 3, pi. And so you'd write it in order as you're going through. I just want you to be aware of that because I will hint to you now that it is coming back on a quiz or a test. Okay, so just be aware. So that's the first idea. What are the types of numbers? How do you classify them and how do you put them in order? The easiest way to put them in order is sometimes to put them in a decimal form first to then be able to order them. Okay. The second main idea from this is properties. And I don't know about your other teachers and how highly emphasized properties were, but these are properties that we expect that through your algebra a couple of years ago you still kind of remember. And so here's the idea. The first one is called closure, and what that means is you get an answer. Okay, so you get some type of closure or end result. And what we're saying is if we add a number a plus b, if we add two random numbers together, whatever they may be, I get an answer out. That's a number. And that's what they're saying. Same thing with multiplication. I can take a and multiply it by b, and I get another answer. I get a real number. Okay? Closure just means that once you do your operation, you get an answer. Okay, so if you need, write that on here. I get an answer. And take whatever notes you feel are necessary. Commutative talks about the direction of doing your operations. What it says is that if I add a number a plus another number b, I could do exactly the same thing as if I take a number a or number b and add it to a. It says that the order that you add them in doesn't matter. Okay, so commutative talks about the order of an operation. The second thing, again, I can multiply a times b, or I could multiply b times a, and I should get the same answer. The associative property, and there looks like there's an extra I in there, I apologize. The associative property changes the placement of the order. So this says first take A and B together first, and then whatever my answer is here, I can add C. Now I'm going to get a number out of that. But I could decide to change what I group them as, and I could say, well, what if I took B plus C first and added those, and then whatever my answer is, I add A to it. So this basically changes the order of grouping. So it changes the groupings, and groupings basically means parentheses, where commutative changes the order. And you'll notice I didn't change the order of my letters here in the associative property, I just changed where my groupings were. Same thing in the multiplication. Instead of doing A times B first, I could decide to do B times C first and then multiply it by A. And again, all it does is it changes the groupings. Okay? The identity basically says that if I do not change it, whether I add or multiply by a number. If I add 0, I know that I'm going to get the original number out. Or if I do 0 plus a, again, I know I'm going to get the original out. Same thing with multiplication. In order to get the original, I have to multiply by 1 in any order. And we show you both orders again to kind of reiterate the commutative property. The inverse says, how do I get back to the identity? Okay, so your goal is to end with the identity. If I take a number and its inverse, this is what we consider the inverse. It's basically what you guys probably think of the opposite. What's going to happen is I get back to the identity. Or I can go in the other direction as well and get the identity. In multiplication, instead of multiplying by the identity, I multiply by its reciprocal, and you'll notice 1a on top with 1a on bottom gets me the identity out. I apologize, that's supposed to be a 1. Okay, now the only problem is a can't be 0 because we don't divide by 0, but that's a whole other issue. We'll talk about that as we go through. Okay. The last one is the one that is most common to you. It is the distributive property. And the distributive property says, if I have a number and I multiply it by a grouping, so I add b plus c, and I take a and I multiply it by that grouping, what I do is distribute the a to each. So I have a times b plus a times c. Okay? Same thing for multiplication. And I'm going to do it this time, it's subtraction or with addition. So we did addition. So let's look at subtraction. What if I took b minus c? Again, that a gets multiplied to both quantities. So I have a times b minus a times c. Okay, and so this is the idea. So what I would like you to do with your group mates, and I'm going to pause the video as you're working here in class, I would like you guys to identify the properties, and what we will end up doing is going through them together. Okay? All right, let's take a look. The first property changes the position of the grouping, which is the associative property, and I'm going to shorthand this, and they're talking about multiplication, so I want to include that as well. The associative property of multiplication, and right now I'm going to shorthand it, and that's okay. Number 2, add something to get back to the identity. This is the inverse property for addition. Okay, again, I'm going to shorthand this. Number 3 multiplies by the identity to get itself. So this is the identity property for multiplication. Number 4 adds 0 to something to get itself out. So because it's coming back to the same thing, again, this is the identity property. But instead of multiplication this time, we're working with addition. Number 5, you'll notice there are no longer grouping symbols, which means it was distributed. And this is the distributive property for addition. So my pen's working. Number 6, you'll notice that first they added the 2 to the 6D, and secondly they took the 6D plus the 2. What did they do? They changed the order. That is the commutative property of addition. Number 7, they multiplied 2 quantities to get back to the identity. This is the inverse then, and you'll notice negative 2 is the inverse of negative 1/2. So the inverse property for multiplication. And last but not least, they added 2 things together to get an answer. And because we're looking to get an answer, this is the closure property for addition. Okay, and again, they're shorthanding this, but I at least wanted you to see kind of the idea. And we need you at least to be able to recognize which property goes with which look. So there's the big thing. Last to look at is conversions. And if you've taken chemistry, this part will probably be easier for you. I'm going to hopefully set this up as easy as I can, though, as we go through. So let me slide this down. And I'm going to just do a couple with you, and then I'm going to let you guys do a couple together. As we look, we want to talk about first some conversions. And these are things, again, from science. Most of these are science that you should know. There are 10 millimeters in 1 centimeter. There are 100 centimeters in 1 meter. There are 1,000 millimeters in a meter. There are 1,000 meters in a kilometer. Again, kilo and millo mean 1,000. This is the one that's not as familiar, so this might be one you want to look at. There are 1.61 kilometers in a mile. Okay, that one's probably less familiar. For us, this one hopefully is pretty easy. There are 12 inches in a foot. And since there are, I'm going to skip down a minute, 3 feet in a yard, there are then 36 inches in a yard. And the last, I want you to focus on this one, and I want to focus on this one, because again, these are three, you know, the starred ones are ones that I can tell you will be coming up again, quiz test related. There are 1,760 yards in a mile if you do some conversions along the way. And there are 5,280 feet in a mile. Okay, and those are things to kind of keep in mind, and we'll show you some of those along the way. But the starred ones you will need to know from here on out. Okay, the time ones I think you're fine with. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, and 52 weeks in a year. Okay, a couple more time ones. There are 365 days in a normal year. We don't include leap years in this. 12 months in a year, 10 years in a decade, and 100 years in a century. Okay, so kind of things to keep in mind. All right, take a look. Let's just show a couple of calculations as we're going. You work 8 hours and earn $60. What is your earnings rate? This means how much did you get per hour? So how much money per hour? I'm going to write it this way. If you're talking about a rate, we're talking division. So let's look at this. We could take my $60 that I made, divide it by the 8 hours that I worked, and you end up getting about $7.50 per hour. Okay. Let's try B. You get 18 gallons of gas at $2.65 per gallon. This is a conversion. And so I want to walk through this a second. I know that I have 18 gallons of gas. Per means divide. So what they're telling me is I know that I have $2.65 for 1 gallon. Per gallon means for each 1 gallon. Now, I've written it this way because in conversions, we're going to multiply this together. In conversions, you want the same quantity on top and bottom to cancel. Because they're asking about cost, I want to keep the dollars but lose the gallons. So I can cancel off gallons if it's on top and bottom. And what you'll notice now is that I just do 18 times 2.65, and you end up getting still the dollars that are left. $47.70 is what it cost me for gas for the 18 gallons. Okay, I wish gas were $2.65 now. I think you can all agree, but this is the idea. Now, what I'm going to want you to do is to actually try these bottom two, and these two are a little bit more in depth, but what I'd suggest is that you start here with D because that's the easiest, and then what we're going to do is together bring that at the end just to kind of verify, okay? So this is the idea as you go through the notes. You want to take the notes along with me. If you have a question along the way, please highlight, star, circle, write your question on your paper, because when you come in the next day, we're going to be talking about those questions that you have. So this is the end of the first video. Tonight your homework will be to watch 1, 2.